Okay guys, we're going to be doing some more normal distributions. Same thing as the last lesson where we're looking at the Desmos to find the calculation or the z-chart, and that's what we're going to look at first is the z-chart. So I'm going to give you just a second to read this. Okay, now it says use a standard normal curve table, so that's our z-chart. Find the probability for the selected 14 to 18-year-old male. So if we look at less than $280, that's our value. So let's go ahead and say 280 minus $261.50 over the standard deviation. And this is going to give us our z-score. Our z-score is equal to 1.1384. Now I'm going to, let's just round that. Since our chart only goes to the hundreds, let's call it 1.14. Okay. Now if we go to our chart, we go here to 1.1, go over to the 4, that's 0.8729. 0.8729 is the probability. There's our answer, because we're looking for the probability. Now remember, this is everything that is less than $280, which is everything to the left on our chart. And that's what our chart tells us. Now we have something that says more than. Okay, so let's go ahead and just figure out the z-score that we're looking for. 270 minus $261.50 over 16.28. Our z-score is 0.5230. You should be able to calculate that. Now, let's go find this z-score. Remember, this is the z-score. So if we go find 523, so we'll just call it 052. And here it is, 0.6985, we'll round it to 85, okay? So 6985, we're going to take that, and since that is everything to the left of 0.52, we're actually going to just simply subtract 1 from that. That's kind of like flipping it on us. So when we flip that, that gives us 0.3015. Okay. So we don't want to circle that because that's not the probability. The probability is 0.3015. Okay. We have to do the same thing on this next one because it is more than. So let's take 250, subtract it from our mean, divide by our standard deviation. Our z-score for that is 0.2389. Okay, and we say 0.23. Oh no, I'm sorry, that is actually the, this is the value. Okay, so we would subtract that from 1, and that's going to equal to 0.7611. Sorry, I had already calculated that and wrote down the wrong answer. So the actual z-score was, let me find it here for you first, 250 minus 261.5 divided by 16.25. The z-score was actually 707. Well, we can leave it at that because we're going to round it to 0.71, and it was negative. So if we go up here to 0.71, which is that 2389, okay? Because this is 0, 0, this would be 0, 1. So negative 0.71 is that. That equals that. This is the z-score. And now this is the probability. All right. Now, here we have the ones that are in between. So remember on our graph when we had, if we look at this, we would have something like this, because the mean is $261.50. This would be $240. This would be $275. We're just looking in between here. Okay. So we're going to take the 275 one, and then we're going to subtract the 240 from it, because that's our probabilities to the left of the mean, or the left of the z-score. Okay. So let's do that right quick, which means we have to find both of these values. 240 minus $261.50 divided by $16.25. And then we're going to do $275 minus $261.50 over $16.25. And that's going to give us our z-score. So the z-score for the 275 is the one we want, right? Because that's going to be everything to the left. So let's do it first. If we do that first, we're going to say 275 minus $261.50 divided by 1625, and that is 0.83. Okay? Now, let's do this one up here. This one's going to be negative, and that's going to be negative 1.32. Okay? Now, let's find, those are z-scores. So let's find the actual probability here, and then we can subtract it. Okay, let's start with 8.3. 0 positive 8.3 is going to be right here. So it is 7.967. 0.7967. That's the probability. Now let's find the negative 1.32. Negative 1.32 should be 0.934. Okay, so those are two probabilities. Now, like I said, I'm going to take the 275 probability and subtract it from the 240. So let's say 0.7967 minus 0.0934, 3307. Okay. So the actual probability that falls between those lines is right at 70%. 70% of the values. Okay. So that's what it means. That's what it wants us to find. That 70% of the lunch plan falls between $240 and $275. That's where the majority, 70% of those values are. All right, let's go to page 2. Now this says to, well, it says continue to do the same thing, right? Using the tables chart. Okay, we'll keep doing the table. So it's the same thing. Only thing that's changing here are values, because we're looking at females now. Okay, so we're going to say less than 225 is 225 minus $215.20, all divided by $14.85. The z-score then is 0.6599. So let's go look at our chart. 0.65, 0.65 is 7422. 0.7422. So 0.7422. And we need to write this. That's the z, and then this is the probability. Okay, and we don't have to do anything to that because it's talking about less than 225. Our scores, our z chart, tells us everything to the left, so that's what we want. Now we're looking at less than 200. So we're going to look at this. You should be able to think right now about, is this going to be more values? Is this going to be greater than the 74%, or is it going to be less than? Well, it should be less than, because this 200 is less than 225. Okay? This number will actually be found in part of that, right? It'll be counted in that. So let's do that. That gives us a z-score of negative 1.023. And now let's go look at negative 1.02. Negative 1.02. And that is 0.1539. 0.1539. Once again, that is less than, and a whole lot less than. Whole lot less. All right, let's move over here. Now we're going to do the more than, which only thing you remember whenever we're doing more than, all you have to do is take one, or find your probability and then subtract it from 1. Okay? So, let's do 250 minus 215.2 divided by 1485. The z-score is 2.3, and we'll call it 4. So if you got a standard or a z-score, which is kind of your standard deviation, how far away that is from the mean, there can't be that much of a many values under this normal curve. There can't be, because you're past 2 standard deviations. So let's find 2.34. 2.3 is here, and then that's 0, 1, 2, 3, 4. Now remember, that's 9904. So let's go back, 9904. So this is 9904. But remember, we're looking for more than, so we're going to subtract 1 from that. So 1 minus 0.9904, and that is 0.0096. So barely even 1%, and we'd have to round it to get 1% of the values. So whenever you see more than, it may do you well just to say 1 minus that. And then just work it out. That's your z-score, subtract 1 from your z-score, and there's your answer. Okay? Let's do between. Okay, so now I'm going to start with this one this time, because I like starting with my farthest right value, because we want to do everything to the left of it. Okay, 14.85. That value is 0.32. Now, let's do 190 minus 215.20 divided by 14.85. And that is negative 1.7. Okay, so I'm going to move over a little bit more if I can here, and I'm going to write those down here in the explanation, okay, or on B. So we want 0.32, so 0.032 is right here. 0.6255, so this is 0.6255. Okay. Now we're going to subtract negative 1.7. So let's go up here to negative 1.7. Let's just call it. We'll write all that out. 0.446. 0.446. So when we do that, we subtract, we get 0.5809. That's the probability. Now, we did -1 because we're looking in between two values. We're not just looking all the way to the right. Okay? We're finding values in between something. So you just subtract the two probabilities together. Okay? So explain the meaning, and so B is talking about explain the meaning. That would mean that your lunch value or your meal plan value is your monthly food cost. Your probability of it costing between $190 and $220 is about 58% of it costing that. Let's do page 3. All right. It says, from example 1, using a graphing calculator and without using z-scores, find the probability rounded to the nearest tenth. Okay? So what we would do is, I'm just going to plug that into Desmos for you and show you the answer. I'm going to show you how to plug it into Desmos. So if we have between 260 and 265, I'm going to come down here. I'm going to type in normal. I'm going to try to at least. Normal dist. And remember, for our male, the mean was $261.50, and the standard deviation was $16.25. Okay. Now we want to find the cumulative probability. Okay. So we're going to click find cumulative probability, and what are we looking for? Well, if we go back to our problem, 260 to 265. So between those two values. So all I'm going to do is type in 260 and 265. And there is your probability, 0.122. So that's all I would write. 0.122. All right. So we want at least $252. Now, whenever you think about it, and whenever it says at least, you're going to be talking about everything that's greater than that, right? So I'm just going to come back here into Desmos. And I'm going to type a minimum of 252. And I'm going to take away this max here, and let's see if it calculates it. Okay, it does. You don't have to type in the infinity symbol or anything there. It automatically assumes if nothing's there that it's going to infinity, so that would be 0.72. Alright, so I'm going to come back here. So you've got about a 72% chance of it at least costing that. We'll call it 721. Okay? Now, let's go over here to at most 248. Well, when you do at most, that would be the max. So 248. And we would get rid of this minimum. And The reason why it's not showing up here on my graph is because I got such a crazy values put in for my X and Y, but we really don't care about that right now. We're just going to look at the probability, which is 0.203 here. Okay, 0.203. That is simple enough, right? We just go look at our desmos. Now, let's go to page 4. It says, still looking at exercise 1. Now, exercise 1 was talking about the cost plan for females. Okay? So, in exercise 1, if you calculated the probability that the monthly food cost for a randomly selected 14 to 18-year-old female is $190 to $220, with the probability that the monthly food cost for a randomly selected 14 to 18-year-old female is between $195 and $230 be greater or smaller than the probability of 190 to 220. Well, let's just draw it. The mean for exercise 1 was $215.20. Now, if you look at 190 to 220, this is 190 to 220. You're talking about the probability that flows right here, or that falls right here. Now, when you look at 195, let me try and do that in a different color. 195 to 230. That may be on over here, actually. You think that's going to be more or less than? Well, it's probably going to be greater, because your range here is $35. Your range here is only $30. Okay, so this is going to be greater. Now, let's go back here. Do you think that the probability that the monthly food cost, this is B, do you think that the probability of the monthly food cost for a randomly selected 14 to 18-year-old female between $195 and $230 is closer to 50, 75, or 90%? Okay, well, I should have just left my chart drawn here. If this is 215, and we're looking at 195 to 230, I need to think about what was my standard deviation actually. Okay, my standard deviation, for example, 1, or exercise 1, was about $15. Okay, so this would be $15 plus, and this is only $10. No, this is $20 here. Okay, so we're 1 full standard deviation to the right, and we're a little bit more than 1 standard deviation to the left. Okay, and we talked about if it falls between 1 standard deviation, the empirical rule says that is 68%. Well, this is a little bit more because we're going to be on over here, so we're going to say that's about 75%. Now it says, using a graphic calculator and without calculating. Okay, so now it just wants us to actually find the probability. Okay, so let's go back to Desmos, and let's, I'm going to move that up. I'm going to just go to number 10. So what we're going to look at is the normal distribution again. And the mean was $215.20. And the standard deviation was $14.85. And I'm going to find the cumulative probability for a minimum of $195 and a maximum of $230. And our probability is 0.75, so we were spot on, 0.75. Now, it says, how does the probability you calculated in part C compare to the probability that you would have obtained using the table of a normal curve? Okay. Well, the only way we can compare it is to find them. So let's find them right quick. We would say, I start off with the big ones. Remember, 230 minus $215.20 over $14.85, and that gives me a z-score of 1.36. Now, if I do 190 minus 215.2 over 14.85, that gives me a z-score of 1. -1. Okay, so that's a -1. So now let's go find the z-scores probability. 1.36, 1.3, now let's go over to the 6. 1.36 is 1.1. Well, let me go back. I'm not sure what my number was here. 1.36. So if I go back to 1.3 and over to the 6, I have 9131. Okay. So let's write that down. 9131. Okay. Now, okay. So now we would go to our 1. Well, that's actually -1. So let's scroll up to 0.1587. 1587. And if we are to subtract that, 2, 3, 0, 1, 4, 8, that'll be 5 and 7. Yeah, so there we go, 7.5. Very close. And I even cut it off, so let's see what it actually was. 3.6, and we got 4.3. So yeah, extremely close by doing either the z-chart or the calculating with a computer. Now, let's just look at some things. What's one advantage of using a graphing calculator? Well, I think you would all say that it is much faster. Okay? In exercise 1, you calculate the probability that the monthly food cost of a randomly selected female is at most $200, with a probability that the monthly food cost of a female is at most $210 be greater or less than the probability for an at most $200. Well, it's going to be greater for at most 210. Why? Because it's going to cover more. If this is 200, well, this is going to be 210. And if it's at most, we're talking about everything below it, right? So it's going to be more. It's going to be greater. The probability is going to be greater at 210 as we're talking about it covering more. Do you think the probability that the monthly food cost is at most 210 is closer to, okay, so now we got to think back, what is the mean? The mean of the female was, we're talking about female here? Yeah. The mean of the female was $215. So it's going to be over here. I know it's not actually drawn to scale here, so let me redraw that. So if we were to actually draw this, this would be 215. Here would be your 210. Here would be your 200. And we're talking about this one's going to be greater, of course, but what is it going to be? Well, it's below 50%, right? So we can scratch that out. But what was the standard deviation? Well, the standard deviation was about $15, I think. Yeah, $14.85. So you're only going to be a little, you're not even going to be close to 10%. You're going to be at 30% or more probably. Okay, so because the one standard deviation at 15, with this would be one standard deviation right here at 200. Okay, let's go to question number H. Using a graphic calculator, what's the probability of at most 210? Let's see if I can do this real quick. 210 at most, so let's get rid of this. Let's go to 210. Well, at most it's going to be 0.363. 0.363. What about at least $235? At least would mean the minimum, and that is 235. And I know that's not correct as most, but I will change it here. All right, so 0.09, only about less than a 10% chance, right? 9, I think it was 1. So there you go. So what else we got here? Okay, this talks about using a spreadsheet. You could actually put all this into like an Excel spreadsheet. We're not going to take the time to do that. That's like nowhere close to being what we would want to do. Okay. We will look at this right quick. It says the reaction times of 490 people were measured. The results show the frequency distribution. Okay, I'm not sure what reaction times we're talking about, but it says construct a histogram. This might be complicated, but let's see. So it looks like our frequency is only going to go up to about 250. And we'll do increments of 2 or of 50. Okay. Now these are going to have intervals here. So if this is 0, let's do intervals of 0.05. And I need to stop at 4. Good, because that's all I remember. Okay, so what was the frequency of 0? We don't have anything for 0 to 0.05 because that's just too fast. You can't react that quick. So here we're going to have a frequency of 0.1 to 1.5 is going to be 9, so it's going to be almost nothing down here. It's going to be barely above the line. Okay. Now from 1.5 to 0.2 is going to be 82. Okay. 0.2 to 0.25 is 220. Okay. 38 and 37, so we're getting back down here to nothing almost, and 4. Okay, so now I can tell you that this says, looking at the histogram, do you think that the normal distribution would be appropriate model for this distribution? Well, sure it would. This is very much a normally distributed. All right. So it says the mean of the reaction times for these 490 people is 0.2377. Standard deviation of the reaction times is 0.0457. For the normal distribution, what is the mean? What this mean and standard, for a normal distribution with this mean and standard deviation, what is the probability that a randomly selected reaction time is at least 0.25? Okay. Well, I want to come back over here, and I just want to do another normal distribution calculation. If I can spell normal. And so if you notice there it was in italics, and then it went to, so when it's in italics, it means there's no function like that. So if you keep typing and you finally find the actual function, it will go to a regular font or non-italicized. Okay, so we had a mean of 0.233. Nope, 0.2377. And then the standard deviation was 0.0457. And it wanted you to find the at least 2.5, so that would be a minimum. Oops. Put these off here. A minimum of 0.25. And that gives you the calculation there of 3939. So we'll just call that 0.39. We'll call it 3. Actually, we round to 4, but there you go. Now, the actual proportion of these 490 people who had a reaction time that was at least 0.25 is 0.365. This can be calculated from the frequency distribution. How does the proportion compare to the probability that you calculated in part C? Does this confirm that normal distribution is an appropriate model for the reaction time? Well, at 0.393, if we were to subtract 365, we're only off by, what is that, 28? So not even 3%. Okay, so yes, this would be very close and would and indicates that it is normally distributed. Okay. So there that is. Let me see if I have the lesson summary here. I do. It says the probabilities associated with normal distribution can be found using z-scores and tables of standard normal curve areas. Probabilities associated with normal distributions can be found directly without using z-scores using a graphing calculator. When a data distribution has a shape that is approximately normal, a normal distribution can be used as a model for the data distribution. The normal distribution with the same mean and standard deviation as the data distribution is used.